AI is evolving at warp speed, but what happens when those complex systems fail? The answer isn't just more code, it's robust, reliable operations. This video uncovers how SRE principles are the key to unlocking stable, scalable, and ultimately successful AI deployments. Don't let your AI future be a house of cards. I'm your host, and today, we're diving into why SRE is critical for AI in 2025. In 2025, AI is everywhere. From self-driving cars to personalized medicine, these systems are no longer a nice-to-have, they're foundational. But this explosion of AI innovation brings a new set of complex problems. The big issue? AI systems are fundamentally different from traditional software. It's not just about a server crashing. An AI model can silently fail, making inaccurate predictions without throwing a single error. This is known as silent failure, or model drift. The data pipeline can get corrupted, the model can become biased, or the hardware can hit a performance bottleneck that no one sees coming. A traditional ops team is simply not equipped to handle this level of complexity. Think about it. A standard application gives you a clear error code. An artificial intelligence system might give you a perfectly fine-looking result that is actually dangerously wrong. This is where SRE comes in. SRE, at its core, is the practice of applying software engineering principles to operations. For artificial intelligence, this means we stop treating ML models as static objects and start treating them as living, breathing systems that need constant care and attention. Let's break down how SRE's core principles apply to AI. For traditional software, an SLO might be 99.9% uptime. For artificial intelligence, we need to think beyond that. We need machine learning-specific SLOs. This could be 99% of our model's predictions must be completed in under 200 milliseconds. Or the accuracy of our fraud detection model must not drop below 95%. We set these targets, and the difference between our actual performance and the target becomes our error budget, which allows us to balance shipping new features with maintaining reliability. Traditional monitoring is like a car's dashboard. It tells you if the engine is on or off. But for a complex artificial intelligence system, you need a mechanics diagnostics. You need observability. This means being able to answer arbitrary questions about your system. SRE for artificial intelligence focuses on collecting and analyzing key signals, data quality metrics. Is the input data fresh and consistent? Model performance metrics. Is the model's accuracy, precision, or recall changing over time? Infrastructure metrics. Is the GPU overheating or the memory running low during inference? The repetitive manual work in artificial intelligence ops is what SRE calls toil. This can be retraining models, manually checking data pipelines, or deploying new versions. And SRE's job is to eliminate this toil through automation. By automating the MLOps pipeline, from data validation to model deployment and rollback, SREs free up valuable time for AI engineers to focus on what they do best, building better models. This is where things get really interesting. In 2025, SRE isn't just for artificial intelligence. SRE is being enhanced by artificial intelligence itself, giving rise to a powerful new discipline, AIOps. AIOps uses artificial intelligence and machine learning to analyze the vast amount of data generated by our systems. Instead of a human sifting through thousands of alerts, an AIOps system can predictive analytics. Predict a potential system failure hours or even days before it happens by spotting subtle patterns in the data. Intelligent alerting. Drastically reduce alert noise and fatigue by grouping related alerts and prioritizing only the ones that truly matter. Automated incident response. In some cases, AIOps can even trigger a fix automatically, like scaling up a resource or restarting a failed service. AIOps is the SRE's secret weapon. It allows SRE teams to move from being reactive firefighters to proactive system architects. To really drive this home, let's imagine a scenario. A large e-commerce company launches a new artificial intelligence-powered recommendation engine. It's a massive success at launch, driving huge sales. But a few weeks in, the the SRE team starts noticing something strange. The latency for the recommendation service is slightly higher than expected, but within acceptable limits. No alarms are triggered. The team is under pressure to ship new features, so they let it slide. What they didn't realize was that the artificial intelligence model was trained on data from last year's holiday season, and it was now struggling with new, trendy products. The latency was a symptom of the model's internal struggle, not an infrastructure issue. Without SRE-specific observability, the subtle performance degradation wasn't caught. The model's recommendations became less relevant, leading to a slow, silent decline in customer engagement and a huge loss in revenue. An SRE-led team would have had an SLO on recommendation relevance, or click-through rate. They would have seen the subtle drop and been able to take action before it became a crisis. They would have an automated pipeline to retrain and deploy a new model. This is the difference between a successful, sustainable artificial intelligence product and a house of cards. So, if you're an artificial intelligence engineer, a developer, or a business leader, where do you start? Define your reliability. What does reliable mean for your artificial intelligence system? Define clear SLIs and SLOs that go beyond just uptime. Instrument everything. Make sure you're collecting not just system metrics, but also model-specific metrics. Embrace automation. Look for opportunities to automate manual tasks in your ML ops pipeline. Adopt a blameless culture. When things go wrong, focus on the system, not the person. Learn from failures to build a more resilient system. The future of artificial intelligence isn't just about building the most intelligent models. It's about building the most reliable and trustworthy ones. SRE is the missing link that connects cutting-edge AI research with the reality of production-grade systems. By embracing SRE principles, we can ensure that our AI innovations don't just work, but they work consistently, scalably, and sustainably. That's it for today. If you found this video valuable, hit that like button, subscribe for more insights, and let me know in the comments.